Welcome to the Scala Symposium. The picture shows what a symposium is supposed to look like. Symposium means to drink together. Unfortunately, Intel generosity did not extend to provide large quantity of alcohol, so you have to listen to me while sober, for which I do apologize. On the other hand, you also don't see a bunch of geeks dressed in toga, which is something to be thankful for, I guess. So let's move on. And a little bit about me, mostly because that way will give you an insight what is my perspective. And I'm an applied researcher. I started my experience in IBM, first where I'm more researcher, and I became progressively more applied when I moved to Yahoo and then eBay now. And I'm most interested in data mining, machine learning, and ranking. And as a researcher, I see the implementation part of my job, not only as a hobby, but as an important part, but in which I don't have to do, but I want to enjoy. So I tend to be a bit picky about my tools. And I strongly believe that you should pick the right tool for the job. That when you look for on Google, these are the two top images you get, right? And it's not whether the tool is right or wrong. I mean, the Mac are excellent computer, but it's probably not the best way to cut a cake, right? So the consideration we'll make are coming from a specific context. And I will try to give you a simple way to decide how to pick a tool. So in my job, this is the kind of question I ask myself frequently. Do you know what you're doing? If the answer is no, in technical terms, we call this research. You just have no freaking idea what you're doing. Yeah. So your objective is to reach understanding, right? What the research is about. Somebody tells you, oh, what about, do people buy pink iPhones? Maybe. Why or how? So you want to have a tool that is interactive, exploratory, incremental, flexible, and is a lot of ready, little resourcey program packages ready to go without a lot of effort. R is fantastic for this kind of use cases, much better than any kind of Scala stuff out there. Not because Scala is a bad tool, but it's a different use case. When you know what you're doing, that's called engineering. Your problem change is not about finding out what you're supposed to do, but making sure that it does correctly and with a right level of performance. And then where you really need robustness, scalability, efficiency, and the ability to reuse your code because you really care about it, will use a lot of time, will be deploying a lot of different environments, and then where Scala really comes into its own. It's a very bimodal step. So, and why R? Well, this is the definition from the R page. R was designed for approach in integrated fashion, data manipulation, calculation, and graphical display. Humans are visual animals to a large extent, and the ability to have everything at your fingertip in a very integrated fashion is extremely powerful and is very, very efficient when your objective is to figure out what the heck you're trying to do. And then our secret weapon is CRAN, the repository of R packages, where as yesterday we have 4,724 packages. An R package, for people who are not familiar with it, is a relatively large collection of code for a specific purpose. So if you want to do support vector machine, principal component analysis, gradient boosted trees, or whatever was published yesterday on some statistical journal, they're normally all there, actually. When a new statistician come out with a cool new idea in data mining, they probably create the R package even before the article because that's the way they research in the first place. So for you as a scientist, it's fantastic because if you want to find out, does gradient boosted tree work better than random forest? Well, it's right there. And just to give you a flavor here, what happens all the time, you have some piece of data that you kind of know where it comes from. In this case, since we are in eBay, I have some statistic on everything from the camera vertical in eBay. Basically, we have something like hundreds of categories. Camera, lens, and accessories, and I have how many clicks we got, what we did with them, and who bought them, impression, and all this kind of information. And R is just fantastic for poking around with them. So, sorry. Sorry. let me make it minimize. So this is the R REPL. You're used to the Scala REPL. Some of you might have seen the R REPL. This particular UI is called RStudio, which is an IDE for R. And, well, you have all this nice tool, right? You can read a CSV file, comma separated, right? So you just say, you assign to somewhere else. And now I have a variable. I can poke around, and this tells me, OK, this is a variable that has some information. There is a leaf ID, all stuff you don't care. What I wanted to play around with is I have the number of impressions, how many times an item of the specific category was shown to the users. I have how many times was bought, how many times was clicked upon, clicks there. And I calculated the sale over impression, all this kind of cool stuff. So but what is really useful is, remember, I don't know what I'm doing, right? I'm just poking around the data. So for me, it's really critical to be able to go there and see, OK, what the distribution of the number of sales across all this category. And I just look at this. It tells me, for example, the mean is a kind of a useless metric here. It's a strongly long-tail distribution. I should not even think about doing a mean here. You know, I can ask question like, for example, given a category, how does number of clicks correlates with impression, clicks with impression. Let's put on the x-axis impressions, imps, and clicks plus geo point. Oop, was clicks missing? Thank you. That's interaction for you. There you go. So, well, nice. Seems to be a relationship between the number of times we show something and the number of times it's clicked upon. It looks roughly a linear relationship. I can easily check, for example, I put a smoother on top of it. And looks pretty linear. If I don't like that, I can method equal linear model. See, very quickly, I look at the data, poked around it, get the feeling of the ranges involved, can see whether the linear model fits my data well. Huge amount of information that I didn't know before. And I didn't care whether this was scalable. I didn't care whether this is type safe. I didn't care whether this is functional. Right? That's not what I'm trying to do right now. My objective is rich understanding with the minimum amount of effort, be interactive, accrue information very, very quickly, and figure out what is going on. And the plotting package that uses ggplot makes extremely nice looking plot, which is important to tell to your manager or even do publication. You can save on as PNG to send on in an email or put on a website. You can even put in a web server so that the thing run and creates. You know, you can very quickly hack together something that looks interesting. You can even use one of these 4,000 packages. For example, there's one that is called TreeMap. That this is, as I say, is all the camera categories. So this is a little bit longer line, but this is one line, or this one is just two. And one question you might want to ask: where are click-through? What I'm missing here? Oh, I called it the wrong way. X allows you to very quickly try something pretty complicated. That is, we have a categorical tree structure. There's a camera and accessories, each organized in a taxonomy. So we map the number of impressions to the area of the square. You map the color to the click-through, for example. And you map the category structure to these blocks. So the entire category has this subcategory. These lenses and filters contain filters, lens adapter, and et cetera, lens food, and so on, right? So very quickly, I can see, do, for example, click-through follow the taxonomy structure? Look at this, say, no. What I would expect otherwise would be, for example, this is all very bright, a lot of click-through. And going down, it tends to be consistent, but it seems there is no relationship between the taxonomy and the click-through. This is important because a lot of time, there is taxonomy you find, you want to aggregate on them, you think you will learn something more on if you know the parent of a particular taxonomy or data, whatever it is, and very quickly you can dispossess you of misunderstanding what the data is about. Many times we run a Hadoop job that transfer a day, and 95% of the data is all zeros, right? Because it didn't remember a specific use case where, For example, on eBay, a huge amount of query are empty string. And you might think it's stupid, but it's not, because when the browsing, you can go through the category tree. Only you forget about that, and you run your job, and your mapper dies miserably because all the empty string browsing query hit the same mapper, and the thing dies. Okay, this was a little bit giving you the feeling of R. What is the time? 10 minutes. You can even do something a little more fun, like you decide that you are a real data scientist. You want to do gradient boosted trees, which is, for people who are acquainted with that, is the method of choice to predict things. So what you can do, you can say, well, can we predict the number of by looking at the number of impression plus the number of clicks plus the, let's say, the cellular impression. Well, no, cellular impression is cheating, sorry. Plus, let's say, the L2 categories, right? And I pass my data, X, and let me see whether this works. Beans, not found. What is beans? Are they called beans? Let me see how they call it. Yes, they are there. Formula equal. Okay. Very good. So this, again, is a, you can do some assumption, but very quickly I can look at my model, and it tells me, well, the number of impression is the most important features, the number of clicks the second most important features, and the level 2 category doesn't matter at all in trying to predict the number of sales. Again, beyond a specific example, with almost zero cost, I could find out whether a state-of-the-art learning algorithm can help me in this particular case. And yes?
Is this usually a subsample of a much larger data set?
It's an aggregate. It's an aggregate. It is basically the entire inventory under the camera category, but it's not the raw data. So yes, it would be nice to have every single sale as a separate record. R make the fundamental assumption that everything fits in memory, which is only helped you so much. And so that's bring me to the second part of my talk. What is it? Okay. That sometimes you need to use something else. When you want to, this data, for example, is a text file that is 20K, is definitely not our raw data. Our data is much bigger than that, and it lives on a Hadoop cluster. So in 2010, we needed to get this data out so we can actually start mucking around in R, for example. How do you get the data down to reasonable size out of the Hadoop cluster? And at that time, there was what was available on Hadoop was you either program it in Java, which is a huge amount of pain. Otherwise, you can use Pig, which is still around, and which reduces some part of the pain to postpone it when it really matters. So in some sense, Pig makes it really easy to get started, and it's absolutely impossible to debug. So you can easily get your toy program starting very easily, but when you start to believe, oh yes, can do this, and you start to have real program that breaks down catastrophically, and it doesn't really work very well. And there is high for the SQL people who wanted to just to take the script and run it on Hadoop. It's good for relational thing, but in eBay we have Teradata, and that's a very large database that does SQL properly. So in some sense, if you want to run SQL, you might as well use Teradata. Hadoop streaming is a way to cheat in the sense you just want the data and you want to do something on the fly, and that's okay. It works well enough for a relatively simple job. Again, if you need to do something complicated, it doesn't scale very well. Or you do your own. Just to be clear what the pain was, this is kind of a whipping boy by now. Everybody saw the word count in Java. It's really painful, but the point I want to make is that it's all crap. I mean, this is all boilerplate. You take cut and paste. You know, this is the mapper class. The only part where you do anything useful is here, tokenizer. Yeah, these 2 lines that you do actually something useful. All the rest is boilerplate. This is, again, the second part of the graph is the reduced part. The only part where you do something useful is here, right? And you're not done yet because there is still another kitchen list. So again, we look at this in 2010 and say, this is really stupid. MapReduce is an intrinsically functional abstraction with an intrinsically non-functional language, which is, you get this, right? And we weren't happy. Also, so we're looking around, and Scala was the new cool thing among the functional on the JVM language was Scala and Clojure. Clojure is great, but was a little bit more of a stretch, and it doesn't interpret as well as Scala with the Java type system. And we decided to use Scala instead. Now, and yeah, this is kitten. And at the time, we were basically running our own, and then we move on wrapping cascading with my own really crappy interface. Then somebody like Twitter did something much better job than that, scalding. So don't use my, also we didn't release because we were embarrassed, but got the job done. And also Scoobi is also even nicer, I think, API where they are Scala all the way. There is no intermediate step. And what this allows you, oh, well, this is a Scala fact in the middle, so make sure that everybody's awake. And you get this, type safety, right? If you call that and compile, it will not run. So this is the way the word count in Scoobi looks like. First of all, I mean, you read Scala, most of you guys, and it's a lot more readable, first of all, most of it because it's a lot less. I mean, do I need to sell Scala to you guys, or are you good with that? I mean, I think you're probably good, right? So I don't need to preach to the choir, but I wanted to make a point. If you look at the code here, right, basically there I just read a bunch of lines. I take the lines, a flat map, I split them, I map each word to a word plus a count, then I group by the key value, and then I just combine them all, right? Word count. Tell you as it is. Now, the really interesting stuff that is here is, where is Scoobi, right? Scoobi, in some sense, there is the import over there, and there is this crazy D list here, and there is persist down there, but it's gone. And how it's gone is because when you switch to Scala, you start to program functional, right? That's the whole point of switching to a new programming language. And the really brilliant part of programming functional is that what you type here, when you take the style, this is you do anyhow. If I was having 50 lines on my disk, I will do this pretty much the same way. It's not any different than what I do in distributed mode here on Hadoop, right? It's the natural style that you write a functional code in Scala. So the really cool thing is that since I writing this functionally, what Scoobi does behind the scene, it can capture all these functions, make a closure out of them, and steal them, so to say. Normally, when you write the Scala code, it just runs there, and you get the result. When you do this in Scoobi, they cheat, because this dlist actually, instead of executing this thing directly, it closes on them, doesn't run them, and create a DAG behind the scene, and only get executed when you actually force it over there. Scala does pretty much the same thing. But what it makes the really fascinating part of functional abstraction is that you can put all the complexity in your data structure, because the function can be moved, become a movable piece. When you if implemented in Java, there is a for loop. There's an index that goes to 1 to 100, and that imposes a strict ordering on the execution, and imposes that I need to iterate from index array number 1, index array number x, and all the array must be mirrored at the same time, because that's is necessary to enforce the semantic of this operation. If you adopt a functional style, in some sense you abstract over that. You say, I tell you the operation to do, but I rely on the data structure to iterate and execute. That is extremely powerful, because now the data structure can change the thing under the feet without you changing anything. So what happens there is that the data structure can say, I'm not running this one right now. I'm creating a closure that I can serialize, ship on the 160 machine on the cluster, run in isolation, and do the reduce through a two-step downstream and get back in the same place, right? So So I think this is really the money slide. What I didn't like in 2010 was that Hadoop is, let me put it in, it's a bit of a crappy piece of salt in a sense. It's extremely useful. It's a very easy way to waste a lot of time on a lot of machines in parallel with a little effort. But has a lot of limitations, has very specific use case, works well only for embarrassing parallel problem. It doesn't work well for iterative algorithms. It doesn't work well for streaming algorithms. It doesn't work well for a lot of other different things that we're interested in doing. So I was kind of leading to invest a lot of time and effort from me and my team to learn all the details about Pig, all the details about Hive, all the details about MapReduce. It's nice. We need it right now, but I don't see that as carrying us in all the use cases that in the future we will need. So in a crazy way, when you see that the people in future will need, because of distribution, because of synchronous programming, because of parallel processing, will need to reach in a different place to program things, like will be, and probably will be functional. Basically, if you can bet on that, you can sidestep obsolescence on the current technology by overstepping ahead. So in some sense, in 2010, say, let's do Scala, let's do functional, and then they will catch up. So it's normally not a strategy you will propose, but you can avoid to be obsolete by being even much more farther in the future. So you basically, you bet to find yourself where everybody will finally figure it out in a couple of 2, 3 years later, and they will come out. The cool thing is that Chris doesn't like to use Scoobi for whatever reason. I don't know what's wrong with him, but it's the next aisle. And all this code runs perfectly well on scalding after you change this little thing and you change this little thing, or other relatively trivial changes. So in some sense, the fact that you program functionally, say, OK, forget about Scoobi, MapReduce, and all this other crap. You worry about your algorithm. You have some data structure magic that contains the data you want. Which transformation do you want to apply to it? How you parse them? What happens to them? And how do you are supposed to transform? Just express this in the most natural form possible. And then how it actually gets implemented. If I wanted to use parallel collection, I just use this list, and I say .par, and I get parallel collection. So on the same machine, the file fits there. I can run in parallel using parallel collection, which works fantastically well on a single machine, much more efficient than Hadoop. So if my data set is small enough to fit in a large machine, I can go this with parallel collection. My code doesn't change here. Doesn't even know where it's run. It doesn't care, right? I just tell what transformations apply to it. And I can get my parallel collection code. Or it says, no, this is really big. We'll never fit in a single machine. We need Scoobi. And so we go distributed with MapReduce. Scoobi takes out the pain to figure out the specific MapReduce. Or Scoobi, for whatever reason, is broken this week, because that happens all the time. And therefore, we say, OK, we need the result tomorrow, so we can rewrite this thing to work in scalding. OK? The other part is that when you have a real language as opposed to a toy language, I mean, Pig and Hive are nice and well, but they're relatively toy language. You know they are toy language because you need to create a UDF every time you do something serious. Whenever you need to parse something interesting, you need to do some extra function, normally written in Java, just to get a real job done, right? They're very helpful to structure get this piece of data here, over there, and filter and group and a couple of things like that. But when you really need to do complicated stuff, you need to escape to some serious, full-fledged language. The nice part of Scala, once you bind it to functional, you're already in a full-fledged language with all the useful files that you need. So you can take advantage of information hiding, object-oriented programming, all these nice things that you want to use anyhow, because when your data starts to get complicated, you need to use them anyhow to keep complexity under control. So this is pretty much the code that we use to figure out what happens on our eBay logs. eBay logs are extremely complicated. We have literally hundreds of different pages that do hundreds of different things. And no one really knows anymore what each of them does. There is some legend and a little bit of mutually conflicting documentation about some of them. And so it's a continuous catch-up to just understand what the logs actually are saying. But in most cases, you really don't care about which of the 65 different versions of the view item page you are looking at, or the search result page you're looking, because we're mobile, we have the app, we have the the UK version, the DE version, where the old version that we replaced last week, and where there's a new one we are testing right now, right? In some sense, most cases you really don't care. You want to know how many times the user saw this particular item. Right? That's what you really care about. So you want to say, OK, if it's a search result page, just give me all the item version to the user. Abstract the complexity away. You cannot do this in a toy language. You need to have what we did here. We wrote pretty complicated code. Actually, I can show to you because this is good to give you the touch of reality there. What is behind that is, yeah. So these are the kind of code we need to figure out what these events are, right? So let's say what, yeah, the buy item page can be any of these numbers. I need to check whether 16 different flags in a specific case because it might fail that way, or you didn't check out, or it was immediate pay right now, or was turbo lister, super duper, whatever, right? You don't want to know this thing. No one wants to know this thing, but we need to figure it out. And it's all code that I had to write in Scala, and it's all there. And the really fantastic part of Scala is that allows me to write that way, and I can use what in Java is just a set of events, all class absolutely identical, and I need to find out which tags are associated with it, which flags are associated with them. Instead, I transform in a different set of types, each with their own custom parsing code. And text to pattern matching, well, becomes a lot easier to read, a lot easier to explain. And so we did all this thing for Hadoop. And then happened something really interesting. A couple of years later, we needed to do it much quicker. Hadoop is a batch system, right? Every day there is something happening. You take all your log, you copy, boom, you copy down into your HDFS cluster. You have one n terabyte of new stuff to go through, right? So you can data mine the heck out of it. But sometimes you need to be much quicker than that. Particularly, I'm working for the machine learn ranking function. We need to train new ranking on eBay. And the way we create our training set is whenever somebody buys something on eBay, you're there looking at your Hello Kitty phone covers, right? And you really try to find a pink one. So you scroll down, 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 down. And you do searches, and you refine, oh, Hello Kitty with a smile, whatever it is. And then you find it, and you buy, right? Now, when you buy that, in 1 out of 1,000 other sessions of people are monkeying around, not doing anything useful. They're just clicking around, not buying anything. But we want to get the single session that there is a conversion event, somebody bought something, turn around really quickly, and freeze the state of the search engine as it is right now. Because our search engine takes into account what you clicked on, what is a continuously changing system. So we need to get this event, turn around, freeze the state of the world on disk, just scrape the search engine, what you saw the last search before buying something, so we can learn from it. Right? Ideally, we would like to put on the top the one you're going to buy. So ideally, you should not even scroll down. You go to eBay. The first one on top is the one you want. Press buy. You're happy. We're happy. We make more money. Everybody wins, right? So that's what we want to do. To do that, I need to learn what I showed to you that you didn't care about. You have to scroll through. So next time, I try not to do it. And so to do that, of course, Hadoop doesn't work because it's a batch system, and it takes 1 day before you even notice things. So we looked into plugging into the message bus on our data center to get in streaming mode this event coming in. As I said, Hadoop doesn't work in that environment, so we use our own custom code using Akka. We take all the back-end messages and ship it over to an actor that sits there and just looks around all the user what they're doing. And when the event of conversion happens, it turns around, grab the last search, and send over to another actor that is supposed to scrape the search engine. It's relatively simple conceptually. It's just a couple of messages moving around. But the really cool thing is we are able to take all this parsing code, these several hundreds of classes, very complicated parsing code that runs on Hadoop, absolutely unchanged. And since we're clever not to make it depend on any Hadoop library, and using the real-time system now. Great, right? In a single fell swoop, we have a very complicated piece of code that gets reused in real-time application, gives on Hadoop. They're always in sync. Everybody's happy. And when we add the mobile event to the Hadoop side, magically also works on the real-time side. That's where you gain advantage to have a really serious programming language, because you can invest in that environment with relatively good assurance that they will pay off. So that was really nice. And so let's suppose you want to get on the good stuff. You want to have your people let you use Scala at work. That would work for us. I mean, eBay did a kind of culture change about 4 years ago. They suddenly decided they needed to be a technological company. I know it sounds strange, but they decided to do that. And there was real culture change. Say, let's put the engineer and the scientists in charge and let's see what they're doing. So sometimes we get away with much more, like we say, we want to use this crazy stuff. No, we don't support that. We don't care. We just use it anyhow. That's what they did. The people rewriting the search engine. They say, we don't want to use ClearCase anymore. We hate it. We are going to use Git. IT say, why not support Git? Say, we don't care. We just use it anyhow. So 2 months later, IT says, we support Git. The people want to say, we running on Solaris on the back end. We don't like Solaris. We want to run Ubuntu on the back end. IT say, we don't support Ubuntu. So we don't care. We're just going to do it anyhow. And it takes a little bit of sticking your neck out, but sometimes you can get away with it. But let's suppose you want to start in a slightly less disruptive way. What worked well for us was start with something important and new, but not mission critical. You want to give you the chance to fail without the company going down, right? That's kind of basic level. We started with a small team of 2-3 people. That was really critical because we're small. We can move quickly. You can change decision quickly. People relatively quickly get to the same level of expertise, which makes nice, and you learn things more or less at the same time. Try to agree on tools relatively early. If your friends start to use IntelliJ and you use Eclipse, it's not fun because you spend half of the time bitching about the dot project versus whatever else is on. It's not important which one it is, but pick one. If you're a small team, right? In 3 people, you should be able to agree on your tool at least. We picked Maven. It works really well for us. SBT is nice, but Maven was easy to integrate in what else we had, and it was good enough. And honestly, I'm not so hot about build system anyhow. As long as they get the job done, I don't care. So that worked well. Git. And you pick Scala. No? It's cool. It's new. Try to pick in a place where it actually makes sense. You don't want to rewrite your legacy application in Scala. There's no real point. Even if you succeed, what is the interesting part that you're learning there, right? I know it's a big risk. You try not to learn a new thing in a new environment, but sometimes one of the big plus points of functional approaches make a lot easier specific, difficult part of implementation. Asynchronous, distributed, parallel. Those parts, in many cases, is much more difficult to get them right in Java, like in our little case in the real-time system. You could do it with thread and logs, but it would be much more difficult to get it right in Java than to learn Scala and Akka probably. Because once you do it, Akka was a stupid program, it's 2 pages. So yes, you can relatively quickly find out where it works, and you can actually show that, hey, 2 pages, we get it done, it's up since 1 year, never goes down, as opposed to you are still chasing your lock and your null pointer exception. So I think that's a really good point for you. Pick something new and high risk. It's high risk anyhow, so you might throw a little bit more on top of that. At the beginning, don't obsess too much about being pure. I mean, there is good reason for being pure and so on, but don't overdo it. We all started by writing Scala in Java in Scala and all these things. It's fine. It's a learning experience. Just be aware of what is there. We're all learning to use our tool. Try to keep interoperation with Java simple. It's true that you can call Scala code from Java, and it's true that you can call Java code from Scala. It doesn't mean necessarily you need to do all the time. For all our reusable code for parsing our logging, I decided I will not support Java at all. First of all, because it's good for them to learn to move to Scala. That was the whole point. Right? No, new cool toy, I want them to move anyhow, so I'm not going to make it any easier for them to stick to Java. But also because I don't want to write to the minimum common denominator. There is good reason why we switch to a functional style. The fact that, for example, I transform this sequence of events in different classes is convenient because I pattern matching. If I need to read this in Scala, if instance of blah, blah, then cast, else if instance of blah, 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 then cast, it's ugly. So your API does change if you're thinking that most of the clients are Scala or Java. Also, whenever you need to interoperate, that's normally the most complicated part of the language. To know how a Scala object looks for Java needs to know so much about the internal of the compiler you really don't want to know. It's not a job you should be when you're starting out. So keep it simple. You say, in our case, Scala code calls Java code, and that's it. Scala calls the Scala code will call Scala code. And if you can, try to learn one thing at a time. It's good to, people get really enthusiastic, and you can do really cool stuff. But you know, the complexity grows very quickly, and it's good to get a little bit, find your leg first before you start to run around. One really cool thing that I tried to do yesterday, but didn't work so well, unfortunately, was you can take a actor. You know, AK2O has this cluster mode. Basically, you have this actor that can find each other. You have a seed node, and you can create your own cluster. And I tried to do this. Let me show you because it's cool. Do I have it around? Let me see. Yeah. So we had this Hadoop cluster sitting there, and I was deciding, let's steal the Hadoop cluster. So what you can do is, I had this idea. On Hadoop, you know how it works, right? You have a machine that you connect to, and that distributes your job to 2,000 mappers. Now, what I did is, what if you stick an actor in each mapper, and they all connect back to the command line mode, and you create and you take over the cluster, right? You hack a cluster on top of Hadoop, and you can actually do it. In some sense, I was able to run it locally. You can see. Let me see where I can see what it is. Yeah. Yeah. So this is I just took over the activator demo. And here in a mapper, in Scoobi, you can create a new function by calling implementing three methods. The setup, basically when the mapper starts, call the setup method. Then there is the process method when you go over the data that is coming into the mapper. And then there is the tear down method. So you can stick an actor in the setup. Basically, you have this mapper firing up on some of your nodes, and that could connect back to the seed node and create a Akka cluster on top of the Hadoop cluster. And it works beautifully in local mode, but I found out the people in IT were too smart, and they blocked all the ports, so I cannot connect back to my thing. But if I find an open port, I will actually make it run. So the point here, apart from being cool, is the nice part of function style, you put all the cleverness in the language as opposed to put the cleverness in a specific framework or the specific API you're using. And that makes much easier to use two of them at the same time. Normally, if I use a pig, I cannot have communicating process on top of pig. It just doesn't work. The framework controls the execution of your code, and you just ask, what happens, happens. You're not in charge of it, right? And but here in Scala instead, you have much more, since most of this complicated stuff gets pushed into APIs, I can use the Scoobi APIs that enables me to create this mapper and so on MapReduce jobs. And I can also link into the Akka API that allows me to create actors and so on and use them at the same time. Because I'm in control, right? It's not the framework that imposes its will on me, and I can get along as long as I fit in their particular view of the world, but I can actually take over and do something really cool. So there was another thing that, yeah, I think I already talked about this, yeah. This is function programming. Okay, how do you convince your Hadoop ops team to let you use Scala? This was 2010, yeah. Well, there's the way we did it. Chris knows it, but there's your Hadoop job in Java and there's your Hadoop job in Scala. So you just don't tell them, right? They will never find out, right? They will never figure it out. Huh? They look in the class path, they say, what is this Scala thing? Oh, it's just a library we picked up, it's nice, don't worry about it, right? Don't show them your source code, they have no clue anyhow. So, right? We ran for a year without anyone knew that we were running Scala. This production in some weird definition of production, but these are code that actually produce data that ends up in production. This production job, right? As long as it works, no one cares. So don't tell them. Why do you tell things? Right? Just use it. remember, it's much more difficult to object to success, right? One thing is say, there's this weird stuff that no one really else is using, but we think we're cool kids, we want to try out, pretty please, can we use it in production? They say, no, of course, right? But you say, we implemented this thing, we took our effort, it's running 6 months, it's up, and we love it. We want to have more of this. You can start a discussion. Thing we really learn is be careful when you find yourself writing frameworks. At least me as a scientist, if I'm writing framework, means I'm not doing my job. Resist the urge as much as you can. Try to get what is out there. There are a lot of people writing framework for you. Get on it. The learning curve is steep, more than you expect. I mean, we all picked up a language overnight. It's just syntax most of the time. Unless you're well-versed in functional programming languages, is a different ballpark. It's like when we went from imperative to object-oriented. It's not trivial to get really comfortable with it. Documentation and tooling are important, particularly when you get people who have no clue because they are beginners, and you need to set them up. Our biggest pain point is, first of all, you need to get a working Eclipse installation, because so you need a shovel load of memory. Then you need to get all the libraries we need. So you need to have a Maven that works so you can download our libraries. Then you need to have something on which Hadoop runs, which means all your Windows machines are useless, because Hadoop just does run on Windows. So you don't want to run on the cluster as much as you can. You want to run locally. And then you need the whole thing to work magically, right? That's really a huge amount of setup. And you cannot give them a VM. It's a development environment. VM wasted half of your memory on crap. You will never get enough performance, at least not now, on the VM, unless you're a humongous machine, in which case you're wasting it. Pair programming, I find it works really well to ramp up people. And giving talks, writing documentation. Embrace a bit of elitism. You don't need to get everybody from Java to go to Scala. Actually, I strongly recommend against converting stuff. You want the new cool kids and the new stuff to be new. But there's no point in rewriting what works perfectly well in Java in Scala. It's not very interesting. In general, I want to write. I'm programming because it's fun. So I want to work that was not even possible to implement 10 years ago, either because it was too complicated, or because the complexity kills you, or because it involves a synchronous distributed process that you can just not wrap your head around normally. So try to embrace that direction and be selected to where you deploy this technology. And then try to become the standard. The wiki is your friend. So this is the internal page of eBay. It's called Scala at eBay. I wrote it. And the way you become the standard is the little edit button. So you all have a wiki, right? So you press the edit button, say Scala is the standard at eBay for all Hadoop jobs. This is pretty much, yeah, right? And people believe you. I wrote this paper, I wrote this page, and I wrote this nice 7-page tutorial how to get started with the standard platform on Hadoop, that is Scala, and all the documentation. And after a couple of months, people from we acquired a company called Hunch in New York. They joined. They're all there in New York. And then a guy from Hunch comes over to visit the main headquarters, say, we really love the Scala platform. It's awesome. Everybody's using it at Hunch. I say, cool. It worked, right? They're new. They're no clue. So they go on the wiki. They read what is the standard. I tell them what is the standard. Everybody's on board, right? Works. Don't tell them, right? And so, conclusion, since we are almost there. Scala is awesome, but it's not good for everything. Be aware of what you're trying to do. Do you know what you're doing, or you don't do what you're doing? If you don't do what you're doing, maybe Scala is not the best tool. First, figure out what you're doing. R is awesome for poking the stuff very quickly, try all the possible kind of crazy new idea in statistics. Also, as opposed to computer scientists, statisticians tend to be sensitive to get actual correct result from their process. And R is implemented by statistician. So normally you get result that you can stand behind. So when you do run a linear regression from R, normally the result makes sense as opposed to be weird. Learning Scala in function is hard, but is great. But it really pays off. because once you learn to think in that way, all of a sudden a lot of things become easy. So because you invest a lot of effort into get your mind wrapped around the Scala collection classes and the way you do map and filter and all this kind of cool stuff. But then you say, hey, we can do in distributed process with Akka, just new library, pick it up. Or Chris was saying he needed to go and run an SQL code on Teradata. I know it's bad, but sometimes you have to do it. And he said, hey, there is Lick. I can write it as a Scala for loop, and it's type safe. It's awesome, right? So it really pays off because it's a really a new enabling technology. It's the same way when we move from procedural to object-oriented, all of a sudden, a whole new set of things became easy, and it's really cool. And Scala is also where all the action is in these new programming models. So Spark is improving, and it's becoming much more interesting. So if you want to go iterative, distributed process is a new thing to try out. Stream processing is also, there is initiative implementing some of that stuff. So that's where the action is. And if you want to be a little bit on the leading edge, it's a good place to be. And finally, at eBay, we have more data than we know what to do with, and we need help to figure out what it means. So we are hiring, and if you are interested to try it out, we are definitely looking forward to have your application. So, and I think I will conclude it here and open for question, right? Yeah.
So there was a talk about scaling. You guys talked about it.
Yeah.
In Scoobi. So how do you do you have an experience comparing them?
It's kind of difficult. We didn't really benchmark against each other, honestly. I was using cascading before. What I noticed, cascading is a bit more aggressive in running a parallel job in parallel, meaning when you have two data sources that then you will eventually join. Cascading is pretty good at scaling on top of that to run all them at the same time. Scoobi is a little bit less aggressive in that, but Scoobi is much more aggressive in compacting all the process on the same mapper. I had a cascading process that was 3 MapReduce steps, and when I translated to Scoobi, it went in 1, and I thought it was broken. But because I figured out I could compress all and optimize them all out. So it can be a trade-off. Yeah, they're all pretty good.
I would use one of them.
Yeah.
And you'll be happy.
Yeah. My objection to scalding is not that there is any particular bad thing in the infrastructure itself, but it mostly also makes training a bit awkward, because you get them on board, you say, oh, we are using this weird stuff called Scala at eBay, so you need to learn it. Then, and by the way, you're running a Hadoop job, so please learn about Hadoop, and then learn about cascading, because the underlying technology of scalding, but all the documentation in Java. So while you're learning Scala, translate mentally all the documentation in Cascade into Scala while you're learning this. So you say, wow.
So when you combine Hadoop with R,
Mm-hmm.
do you have any interesting tips of how you get data from Hadoop into
Yeah.
R, sampling, aggregation?
Yeah, we will wish would be more sophisticated than that, but we end up doing text files a lot. Chris implemented, but I didn't release it yet, a way to read Avro format in R. Unfortunately, there's a really impedance mismatch because R is Fortran and C code, and Scala is all Java code, so it's kind of difficult to interoperate. There's a couple of interoperable data format, but they don't map well to Hadoop again because they're not splittable and so on. So you can do it at databases with bulk loads, or you go with text files. In general, stuff in R should be relatively small anyhow, because otherwise you kill the machine anyhow. So text file not ideal, but you can make it work.
In terms of sampling?
You need to sample, yes. Sorry? I don't do regression in Scala. I mean, if you think about, there is very few reasons to make regression on an entire data set. It might be cute, but when you do regression on 1 million points, you just increase the error or the square root of the number of points, right? That's all you're doing. So if you take the sample of 10,000 points, you do regression, you get pretty much the same result. There are few cases in which you really need to run machine learning at scale There is few, like, for example, you want to find all the, like text statistics or bag of words model or principal component analysis. That's where it makes sense to reach scale. But most machine learning actually, I mean, medical research, sample size in medical research is in the hundreds because you're killing people, right? If they can figure out with 100 people when somebody's life is at stake, we should be able to figure out with 100,000 samples for most of our things that are just people clicking around, right? So just, again, if you try to figure out what the heck is going on, you don't need to train 20 million models in parallel, typically. Yeah. Anybody else? Yes?
What do you do with medium-sized data? So on the faces, we also use R and Scala.
Yeah.
But a lot of our data falls in this medium space.
Yeah.
It's too, you're running out of memory a lot.
That's a tricky thing. We just buy a bigger machine. No, honestly, I mean, right? It's the simplest thing. It's the most cost-effective. We bought 192 gigabytes of RAM. It's the simplest thing. What else do you want to do, right? You invest 2 years of optimizing the crap out of it? No. Yeah, again, honestly, it's cost-effective to just buy a larger machine. R makes very strong assumption everything is in memory. It doesn't. You can still find stuff that falls in between, but by the time normally you should have figured out why you're doing that, and therefore you can invest in doing a performant and scalable thing. And R is not necessarily the greatest implementation language when you want to have a robust and scalable system. It's just, yeah. Okay. Thank you very much.